Hello everyone, in this video we're going to name the quadrant. So in order to understand trig functions fully, it's always important to know where sine and cosine are positive and negative in which quadrants, and it will help us as we go and do other things with our trig. So first of all, we're just going to go through some examples, and I'm going to draw the little xy axis over here, and we'll talk about each. Now, just a little review. First quadrant, we know that our signs for first quadrant are positive, positive. Second quadrant, negative, positive. Third quadrant, negative, negative. And the fourth quadrant, positive, negative. And just always remember sine is y, cosine is x, and tan is y over x. So sine, for the first example that we have, sine theta is greater than 0. Well, if sine is greater than 0, that means sine is going to be positive. So a lot of times I'll do like a highlight here. Sine is positive above the x-axis. So right here is where sine is positive. And then cosine theta is negative, is less than 0, is negative. Cosine is negative on the right side of the y-axis. And then you'll say, oh, see where they're both the same would be right here in that first quadrant. So the answer to number 1, you would say quadrant 1. And there we go, quadrant 1. And we always label the quadrants with Roman numerals. All right, next example. Sine theta is less than 0, tan theta is less than 0. Again, I'll draw another grid over here. So again, we know sine is less than 0, so that is where sine is negative, would be below the x-axis. Now, tan can be a little bit more tricky, but it's not that difficult. Tan is going to be negative when x and y have different signs, because if you remember, tan is y over x. So if y and x have different signs, then that fraction is going to give you a negative number. So tan is negative in the second quadrant, because that's where we have a minus plus, and in the fourth quadrant, because that's where we have plus minus. So the place where both of these things are true is right here in that fourth quadrant. So the answer to this one would be the fourth quadrant. Next we have secant theta is greater than 0, and cosecant theta is less than 0. Now, a lot of times what I like to do is I like to think about secant and cosecant in terms of sine and cosine. So secant is the reciprocal of cosine. So if secant theta is greater than 0, that means cosine theta is going to be greater than 0. And cosecant is the reciprocal of sine, so if cosecant is less than theta, then if cosecant is less than 0, then sine is going to be less than 0. So when I draw my x and y axis here, cosine is positive to the right, and sine is negative below the x-axis. And the place where both of those are true, again, in the fourth quadrant. And there you have it. That is how you name the quadrant when you're given the signs for the different trig values. Now, sometimes you have to name a quadrant to know where an angle's located. And when we derived the unit circle, there were certain angles that we put around that circle. Well, not all of these angles will be those values that we have on the circle, so we have to kind of estimate to figure out where they would fall. So let's look at the first example that we have here, and that is 2 pi over 5. Now, on my unit circle, there's certain values that we know. Like I know that pi over 2 is here. I know that we have pi over here. We have 3 pi over 2 down here. And we have 0 and 2 pi over here. So I'm going to use these as reference as we go through and work these out. So the way I like to think about it is that pi over 2 is think of that as being like a half. Okay? So when I look at 2 pi over 5, I want to concentrate on 2/5. And so my question is 2/5 bigger than a half or less than a half? Well, half of 5 is 2.5, right? So 2 is smaller than 2.5. So 2 pi over 5 has to be over to the right of pi over 2, or is less than pi over 2. So 2 pi over 5 should be somewhere in that first quadrant. So we would say for that one, that falls in quadrant 1. How about 5 pi over 8? I kind of use the same idea with that. Half of 8 is 4, and 5 is bigger than that. Now, if we come over here and we look at our circle, so pi over 2 is here, pi is here. Pi over 2 in terms of 8 would be 4 pi over 8. I'll write that down so we can kind of see it. 4 pi over 8 would be the same thing as pi over 2, which is smaller than 5 pi over 8. Now pi would, in terms of 8, would be 8 pi over 8, which is larger than 5 pi over 8. So therefore 5 pi over 8 has to be somewhere over here in between the two. So that would be in the second quadrant. Okay? Now let's take a look at 22 pi over 3. Let me erase some of the stuff over here. Okay, 22 pi over 3. Now we know that on our unit circle, values over 3 are on the circle. So for instance, right here we would have pi over 3. Over here is 2 pi over 3. Down here we have 4 pi over 3. And over here we have 5 pi over 3. So 22 pi over 3 is larger than 1 revolution around the circle. So we need to figure out which angle is coterminal to it, and that way we can find out which quadrant it's located in. So what I like to do is I like to kind of like ignore the pi for just a moment, and let's divide 22 by 3. Change it to a mixed number. So how many times does 3 go into 22? 7 times, with how many left over? 1. So think of that as being like 7 1/3. Now let's consider the pi. So what that means is that we're going a distance of 7 pi from pi over 3. So in your mind, you're thinking about like, oh, okay, how many revolutions is 7 pi? Well, what's 1 revolution around the circle? 1 revolution around this circle is 2 pi. Okay, so going 1 time around that circle is 2 pi. So that means 7 pi would be 3.5 revolutions. 7 divided by 2 is 3.5. So 3.5 revolutions from pi over 3. So we're going to go to pi over 3 right here. And if we go around 3.5 times, can we figure out where we'll end up? So we'll go 1, 2, 3.5. We'll end up right there. So that 22 pi over 3 is coterminal with 4 pi over 3, and it's in the third quadrant. So we would say that this one would be quadrant 3. Okay? Now let's take a look at negative 10 pi over 7. So negative 10 pi over 7 is a negative angle, and when you're dealing with negative angles, I always like to look at the positive first, and then I can flip it to figure out the location. So I'm thinking about when I compare to the circle, we know that pi over 2 is up here and pi is over here, and pi would be like 7 pi over 7, and 2 pi over here would be like 14 pi over 7. So positive 10 pi over 7 is going to be somewhere down in here. So negative 10 pi over 7 would be above. Now I need to figure out though if positive 10 pi over 7 is going to be in the third quadrant or the fourth quadrant. So what I want to do is I kind of want to compare it to 3 pi over 2. So 7 goes into 10 one time with 3 left over. So kind of think of that as being like 1 3/7. when I'm comparing to this 3 pi over 2 at the bottom of my circle, 2 goes into 3 one time with 1 left over, so that's 1.5. So I'm asking myself the question, how does 1 and 3/7 compare to 1 and 1/2? Well, 3/7 is smaller than 1/2 because half of 7 is 3.5. So that tells me that 10 pi over 7 is going to be in the third quadrant. So since 10 pi over 7 is in the third quadrant, let me erase some of this, get it out of the way. 10 pi over 7 is in the third quadrant, right over here. Then negative 10 pi over 7 is going to reflect up into the second quadrant. Therefore, negative 10 pi over 7 is going to be in the second quadrant. So the last example that I have here is 5. So let's take a look at just the number 5. You notice how there's no pi associated with that at all. So I know that pi itself is 3.14. So 3.14 falls like right in here. Let me change my pen so you can see where I'm pointing. So 3.14 falls in right here. We know 2 pi is like 6.28. I kind of like, if you can kind of imagine pi as being like really close to 3. So when we're thinking about 3 pi over 2, in my head, I'm kind of thinking, oh, well, that's kind of like 3 times 3 divided by 2, right? And 3 times 3 is 9. 9 divided by 2 is 4.5. 5 is larger than that. Now, I know that this number is a little bit bigger than 4.5, but it won't be much bigger. So 5 is going to be a little bit past 3 pi over 2, so 5 is going to fall in the fourth quadrant. And there you go. We just named the quadrant.